next part of the session.
Okay, thanks everyone for staying in. So this is another service which kind of goes hand in hand with auto scaling service. So this is called elastic load balancing, and whatever fancy name it has. In AWS we have multiple things as elastic, but it is just a load balancer, right? So what it does, it balances the load in a plain English, right? So what sort of load? So it acts as a front door for all the incoming requests from either it can be an internal load balancer wherein one application is trying to access different microservices, or different application, the front end is trying to access your backend logic, or backend is trying to access the database, or any sort of service which a client is trying to access. um, or it can be internet, right? So from internet you have an application, whatever web application you have from internet, so you need a single entry point. So suppose you have a website, example.com, right? So example.com will be fronted by this load balancer, and there you have your members which you can use to balance the load. Sorry, it's my daughter in here. Okay, so this is what essentially in a nutshell load balancer does. So it can be internal load balancer, which is internal facing, external load balancer, internet facing. Uh, just give me a second. See, just give me one. Open it. I'll open it later, please. Sorry, it's like charm of working from home, and it's like holiday started. Apologies. Okay, so uh, it you can have you can have auto scaling group as well, and it will take care of the unhealthy instances. So elastic load balancer actually takes care of unhealthy instances, so it will make sure your requests are forwarded to healthy instances only. So there is an inbuilt health check mechanism. So whatever members you have attached with the elastic load balancer, it will keep on tracking the health of that, right? We'll just go through the whole premise, like how it fits into the greater scheme of things. So uh, let's go to the next slide. Yeah, so see, this is a normal scenario wherein you have some customers. Let's grab a pen. So you have these are your customers, and you have some sort of server, right? So this is maybe an application you hosted on internet. So this all works when you have a small customer base, and that you have one small server, and there is no fault tolerance or high availability requirement, right? But more often than not, this is not the case, right? You want your service to be available, and there should not be a single point of failure, right? In that case, what you have multiple servers serving your content, right? And then there are two ways. So this server has some IP address. So you can front these server, you can make these servers internet facing servers, right? And you can give whatever IP address or the URL of these servers if you have a DNS to your customers. And so some customers will have this, some customers will have this, some customers will have this. This is not a very efficient way of serving your customers, because if this server goes down, then the customers need to be updated, right? And so that's why we don't do that. What we do instead, customer will be given a single URL or a single path, and it will be your applications will be fronted by a elastic load balancer. So this is where that front door analogy comes into picture. So this is the front door, right? So your request lands in here, and it is elastic load balancer's responsibility to distribute it amongst all the available servers you have, all the healthy servers, right? So it will keep on tracking where if all the servers are healthy. If they are, it will send the request, right? Now, what are the benefits? Why should we really use it? I think it is apparent, but let's go through it anyways, right? So it provides a high availability, right? Because it distributes the workload amongst multiple servers. So your application will always be available, because it is very unlikely that all the servers at the same time fails, right? So it provides you the high availability, right? And it provides you the fault tolerance as well, because higher availability and fault tolerance, they go hand in hand, right? So it is keep on performing the health checks to monitor the health of your, maybe you are health checking your daemon, you are running a particular service on a particular port. It will keep on probing that port, that okay, that, because sometimes what happens, your server might not be down, your server may be running, but that service crashed, right? So you can have that, you can keep on tracking that. And if it fails, what load balancer will do? Load balancer will remove that from the active servers list, and it will only send the request to the available one. So it provides some sort of fault tolerance as well, right? And obviously better customer experience, because you have now, mm, the availability of your service is increased, and customers don't have to wait for the desired capacity when you are spinning up new servers. And the services are, the client requests are not disturbed in a way, right? So it provides a better customer experience. So how it actually works, right? So first, what you do, you have your number of servers. So in this case, we have say three web servers. Right? So this one, two, and three web servers, and you register them to some load balancer, right? So maybe this is network load balancer or application load balancer. We'll go through it. So don't worry about the term. Just consider it a load balancer, right? So what it does, a request comes from internet, somebody is trying to use your application. What load balancer will do, it will distribute that request to three servers, because all three are showing as healthy. Now what happens is, if one server goes down, suppose this server goes down, what load balancer will do, when the health check fails, it will remove that server from the active server list, and your customer request will still go through the other available servers, right? And this is where you pair it with auto scaling group, right? So what an auto scaling group will do, auto scaling group will reinstantiate a server. So it will just, this is terminated, it will terminate this server, and it will create a new server, and then health check will pass again, and it will start serving the traffic again, right? So this is how the auto scaling and the load balancer, it goes together, right? Now this is little important actually, so I want you to focus in here, because this is where normally, while architecting, you get confused, and uh, this is where we miss some of the crucial points. See, in AWS, load balancer is not a physical box. Actually, in AWS there are rarely any physical box, everything is a service, right? So when we come from the on-premise environment, right, there we see everything as a box, right? So load balancer is a box, router is a box, firewall is a box, right? And when we translate that understanding into AWS design, and AWS, it was completely different, right? And load balancer is not an exception, right? So it was differently than the on-premise. And how it is different, right? So whenever you create a load balancer, it asks you to select the availability zones, right? It asks you to select the subnets, right? So, and which in turn is it resides inside an availability zone, because subnet cannot cross an availability zone, right? So you select multiple availability zone, and the best practice is to select all the availability zones where your servers are. Because if you don't select those availability zones while configuring elastic load balancer, it will those servers will not be able to access the elastic load balancer service. Because what it does, when you create elastic load balancer, it puts an ENI. So this is an ENI. So it puts an ENI or elastic load balancer instance in that particular availability zone. So this combined is elastic load balancer actually. This is a service, right? But based on what availability zone you select, it puts the instance of that particular load balancer into that availability zone. And once you have your member servers registered with it, it will be able to send the traffic wherever it wants to, right? Suppose you don't associate, you don't select this availability zone, right? Then these servers cannot serve traffic because you do not have um, ELB instance in there, right? So always remember the best practice is, first of all, you should, ideally it is must, right? You must create your servers in all possible availability zones to to decrease your blast radius, right? One availability zone may go down, two availability zone may go down. If you have three, at least one availability zone will be. I mean, it's highly unlikely that availability zone goes down because it is a combination of multiple data centers which are physically apart, like 60 mile, 100 kilometer radius. So, but suppose it goes down, right? You still have other availability zones, so to increase your high availability and fault tolerance. And once you have multiple availability zones, put a load balancer instance in all the availability zone, right? So this is a design principle which it works without that as well. You can select one or two only. If you have say three or four availability zone, it will still work, but you won't be able to send traffic from other availability zones, right? Now there is another design uh, consideration when you configure your elastic load balancer. See, it is an elastic service, right? What does it mean? It means when your number of requests increase, it spins up more ELB instances within the same availability zone, right? What it means is, suppose this instance is capable of uh, taking care of maybe 500,000 or maybe 1 million connections per second for the argument's sake, right? And your connections are increasing, maybe 2 million connections per second, right? So due to the elasticity of the nature, what it will do, AWS would automatically spin up a new ELB for you. If connections still increase, it will spin up new ELB. You don't have to do anything, and it will maintain the list of DNS in the route 53. Customer will still see whatever they used to see, like whatever URL example.com/abc. And they'll still see. AWS will take care of it, but it will keep on spinning out. So this auto scaling thing is already inbuilt as part of this service because it's a managed service. Now, this is where we normally miss, right? So what happens, as a design principle, you must make sure that whatever availability zone you are selecting, whatever subnet you are selecting, it has at least 8 available IP addresses, because whenever these services are spun up, these essentially are the ENIs, right? ENI, Elastic Network Interface, has an IP address, because otherwise, it's not an ENI, right? If you don't have available IP addresses, you may hit a bottleneck in here, right? So that's why it is written in like very small, like one liner in the 200-page documentation, that you need to have at least 8 free IP addresses available. 8 free IP addresses available. It means /28, right? So out of those 16, so /28 will give you 16 IP addresses. Out of those, 5 are not usable. First, last, and rest for the .2 DNS lookup and for the future use, right? So 5 are not available. Remaining are 11. Out of those 11, 2, 3 maybe your servers, right? So be mindful of planning this well beforehand, right? Because you cannot change it later. You have to decommission the infrastructure and do it again. So make sure you have enough IPs available for the capacity expansion. And this is IP address planning is something, I have seen so many customers wherein it goes completely sideways, because in AWS it just works. In 10 minutes you can spin up a 3-tier environment, and it just works. And because it works, the planning becomes an afterthought, right? And this is where we fail. So planning is very important. You have to have IP address planning properly. Otherwise, this infrastructure is not really lasting, right? Just keep in mind, right? Um, Now there is one more aspect which is called cross zone load balancing, and this is also very important, right? So what it means is whenever you have a request coming, so number of requests, if you have say two availability zone A, availability zone B, and you have number of servers, they can be same, they can be different. So here in availability zone A you have two servers, availability zone B you have eight servers, in total 10 servers, right? So whatever requests are coming, they will be equally distributed. If you see, this is not equal in the sense like equal number of requests are coming to availability zone A, equal number into availability zone B, equal based on the server. So if they have 10 servers, then you have 10% of the workload. So suppose there are 100 requests, each server will get 10 requests. This is how we want it actually, right? So equal distribution of traffic. And this is called cross zone load balancing because it is across the zones. Zone means availability zone, right? With ALB, it is by default enabled, right? You have to disable it deliberately, right? With NLB, you have to enable it. It's by default disabled, which is, I don't know why we made it complicated, but it is what it is, right? So you remember that. If you see the uneven distribution, check the cross-zone load balancing, right? What happens if it is not enabled, right? Then what will happen? ELB service will try to send 50% traffic here, right? And it will send 50% traffic here because, it is like two availability zone, 50-50. Then here it will send 25% here, 25% here, and rest all will get 6.25. This is not what we want, right? So always remember cross zone load balancing until unless you have, I don't know what business reason you may have, don't disable it, right? So just remember this. So it will result in an equal distribution of traffic. So you need to make sure that you have it properly. Let me quickly see if there is any question. Let's go. Okay. Okay. What was the? Okay, yeah. For now, already answered it. Yeah. Sorry, actually, I don't see the question, so I have to toggle the screen to see the question. So thanks to my colleagues, actually, they are taking care of. And at the end, if we have some time, we'll take this question. Okay. So that was the cross zone load balancing. Now, types of load balancers. So there are three types of load balancers. Actually, there were four, but one is decommissioned. It was called classic load balancer. It was for classic instances. Honestly speaking, I never saw any classic instance. It was like early days of easy to Amazon, wherein there was a shared pool of infrastructure and everybody was using an instance within. There was no concept of VPC. So everybody was using an instance within maybe a same big VPC. That's called classic instance. But I don't know. So I never used it. Nobody uses it these days because they want isolated environment, which is called VPC, right? So classic load balancer you won't see, but some customers, organizations, government, they are using classic EC2s. They need classic load balancer, but don't worry, I don't think you will ever get to work on it. So mainly we have three. So network load balancer, application load balancer, and gateway load balancer. And this is where when we say like layer 4, layer 7, so these are OSI model layers. So layer 4 is the transport layer, layer 7 is the application layer, right? So let's start with network load balancer. So it works with TCP and UDP both. So these are two transfer protocols, right? So transfer control protocol and user data number. So it caters for both, and it works at layer 4. What does it mean? It means that it will not check the HTTP header, right? So whatever you pass in that header, it won't check. It will only check the destination and the port, right? So if the protocol is TCP or UDP, port is whatever, 80, 443, whatever, it will send the traffic, right? And that's why it is fast also, because it does not pass all three extra layers, right? Session, presentation, and application layer. It does not take care of it, right? So that's why. when you have an application which is latency sensitive and which has uh, uh, too much, well, I'm not finding the right word, but if you need um, millions of requests per second, put it that way, right? You need like hundreds of millions of requests per second, and you need some sort of load balancer to carry to it. Application load balancer will not be suitable for that, right? So network load balancer will take care of those things because it can handle tens of millions of requests per second. uh, so the targets can be IP addresses, it can be containers, right? It can be EC2 instances, right? And it resides within a VPC because it needs an IP, right? And IPs are within subnet, and subnets are within availability zone inside a VPC, right? So this is called network load balancer. So just remember, TCP UDP works at layer 4, and if you have an application which needs capacity, like big capacity of incoming connections, you use network load balancer. Now application load balancer, so it is a layer 7, right? So it caters to http HTTPS. So normally you have web applications, right? They work on HTTP protocol and HTTPS. If you have SSL, and normally everything is HTTPS these days because you don't want to send anything plain text, right? So it's all TLS encrypted. So it works at layer 7, and the targets can be EC2 instances, containers, lambdas, IP addresses, right? So this is the application load balancer for the application. Now gateway load balancer. So gateway load balancer is basically if you have multiple appliances, right? Then so appliances in the sense that you have maybe Cisco firewalls, or you may have Palo Alto firewalls, FortiGate firewalls, checkpoint, whatever appliance you have some proxy appliance, and these are EC2 based appliances, by the way, right? When I say appliance, virtual appliances, right? Then it gives you the front end to those appliances. It will take care of the failure and scaling of those appliances, so you can front all those appliances with this, right? So I have separate slide for this because gateway load balancer is very important for a number of reasons, and I'll go through how what are the design principles for it, right? um, right, so this is a general comparison, like it application load balancer at layer 7, network load balancer layer 4, gateway load balancer 3 of layer 3 and 4, but it acts as a bump on the wire, right? It does not change the packet in any way. These two changes the packet in a way, right? But this is little deep. I don't want to go that deep, otherwise it will confuse you. But it is all available in the documentations. I'll forward you, right? Um, and this is a typical placement of the load balancers, right? So you have a load balancer, then you have some sort of front end, then you may have back end, then another load balancer, and so you can distribute the traffic with these two. So this is the front end load balancer, so this is internet facing. This is the back end load balancer, which is private. You can make this placement. This is just an example. You necessarily don't have to do like this, but this is how you can do it, right? Now the gateway load balancer is actually to front your appliances, right? Now network appliances. What is a network appliance, right? So network appliance is basically, it is in traditional sense in your on-premise environment. You used to have some sort of proxy like Bluetooth proxy, or checkpoint firewall, Cisco firewalls, FortiGate firewalls, or and those sort of appliances, something to logging, something to monitor, IPS system, intrusion prevention system, intrusion detection system. These are appliances, right? And you, whenever you move from on-premise to cloud, you may have your infrastructure and your personals trained on certain sort of appliances, right? Maybe your workforce is trained on Palo Alto firewall. They know in and out of Palo Alto firewall, how to maintain security, and how to do with it, right? And you want to retain those resources, and you want to just maintain that control on the expertise you already have, right? You want to bring it to AWS. right? And this is where you can have virtual version of that same Palo Alto firewall. You can just import all the policies, and then your existing workforce can manage it as they manage on premise, right? You want to do that, but it is not same as on premise, right? So in on premise, these devices, they work in clusters, and they take care of the sharing the states, the flows, and they take care of the failover. But here it is all EC2 based, and there is no native mechanism to failover an EC2. Why? Because so whenever you send a traffic to an appliance, you are sending to an IP address. That IP address is attached to an EC2 instance. If that EC2 instance fails, you need to have some sort of automation, like you need to write a Lambda function to detach that ENI from failed EC2 instance and attach it to the new instance. And this is where the problem comes. And gateway load balancer specifically solves that problem, right? It will take care of, just scaling those appliances, right? So this is traditionally what happens. So you brought your checkpoint firewalls, right? So these are two checkpoint firewall. What a check? I'm just saying checkpoint name is any sort of appliance, doesn't matter, right? So, and from source to destination, you want to inspect some packet because there's a firewall. You want to inspect packet. So your traffic is destined to the active one. Suppose this is active, this is passive. And when this fails, this ENI, right? You need to have some mechanism to switch this ENI to this, and then the request will come from here and then go there, right? And this is all manual, or it can be automated, but you need to write Lambda function and move this. And this is where the problem is. So what gateway load balancer does, it fronts all these appliances. You have multiple appliances in multiple availability zones. You send requests to gateway load balancer. It will keep on checking the health check. It will send to the desired appliance. That the traffic will come back and it will go there. So no matter how many fleet, as long as even one EC2 appliance is available, you will be able to serve it. So this is the problem it solves, right? Uh, so traditionally, what happens when you use a load balancer? You want to send a traffic to internet. So this is suppose some website, right? You want to send a traffic. Where will you send? Suppose it is working in a proxy mode. Proxy, what it does? Proxy is just a fancy term. It is just a NAT device, network address translation plus PAT, port address translation. So what it does, it puts an envelope on an existing packet, and it translates the IP address, right? So what it does, it will send the request. Your EC2 will send the request to the load balancer. Load balance, everything needs to be inspected. So it will send to whatever firewall. So suppose firewall 1. So the source is still there. What it does, so this is internet facing firewall. And this is typically what we have. We have firewall at the perimeter of our network, right? So these are internet facing. So what it does, the source becomes the firewall, which is the internet facing IP address, public IP address. Destination becomes that, right? And what happened here, the source is changed, right? Because there's a proxy mode, the source is changed. Now there is a concept called bump in the wire. Like bump in the wire means it does not alter the packet. So this is what gateway load balancer does. It just sits inline. It's called inline appliance. It just sits in between the source and the destination, and it will not modify the source, right? Source will still be there, destination will still be the same, right? And based on whatever uh, appliance you have available, it will send the traffic, and it will take care of the availability of these three, scaling and all, right? Now at a glance, this is how it there are few components to it. I'm going one level deep, but I think it is important to understand, and there is lot of documentation available. I'll share all the designs, because if you are working with any of the AWS designs, 9 out of 10 chances are you will use gateway load balancer in some way, shape, or form, right? And there are around 6-7 designs wherein you can use this load balancer. So I'm just giving you a kind of a heads up so that it's not completely new to you. So it works based on the endpoints, and I hope you know the endpoints. So endpoints are, they are powered by um, private link interface endpoint. It's an ENI, and behind that ENI, we use our AWS backbone to carry the traffic to your, suppose there is appliance VPC, right? So we created a security VPC or appliance VPC. Then we have our gateway load balancer, and we have whatever firewall, proxy, or whatever devices we have, right? So these are various components. So you have gateway load balancer endpoint. This is actually an ENI, and behind that you have actual gateway load balancer, and your services. You put a route with a next, so route where in a subnet. So wherever this, whichever subnet this EC2 resides in, you put a route saying, suppose you want to inspect everything which is going out. So everything which is going to internet, 00 is like everything, go to this endpoint when the traffic comes. So there is a protocol called Geneve protocol, but it will be too deep actually. So Geneve is basically an encapsulation protocol like, GRE. So what it does, it just it creates a tunnel, it sends the packet, whatever firewall it goes to, it inspects, drops, logs, blocks, whatever you want to configure firewall with, it does that, and it sends the traffic to the destination, right? Here in the whole scenario, source does not see any change, destination does not see any change. Everything here is transparent, right? So yeah, just remember how it works. And yeah, this term, in case you don't know, there is a nice video. If you search AWS hyperplane, so most of the AWS high available service, like all sorts of load balancers, route 53, they work on AWS hyperplane. So hyperplane is basically a concept wherein we say, like, we have, suppose, gateway load balancer, highly available service like gateway load balancer. What the hyperplane concept does is, it puts the instance of that service in every data center, like multiple racks of every data center of every availability zone of every region, right? So in a region there are, say, two availability zones. In every availability zone there are three data centers, suppose, and every data center there are 1,000 racks, right? So out of those 1,000 racks, there may be couple of, I don't know the actual number, but say 10 racks or 100 racks. That service will be there, right? And it will be distributed, so it can avoid the noisy neighbor problem, right? And it will have in every data center, in every availability zone of that region. So that's why this service is highly available. So for this service to fail, all the data centers in all the availability zones need to fail, which is highly unlikely. That's why we call it kind of high available service. And these are the partners. So we have all major security partners with us, so you can use these devices. So you don't have to, do not necessarily have to retrain your resources. You can use that. Um, and this is a north-south inspection. So when we say north-south, east-west, right, it is just a term in networking. Like north-south is when there's internet to your infrastructure. East-west is within your infrastructure, right? VPC to VPC, north-south is internet to your VPC, or VPC to internet, right? So suppose this is the request. So from internet, you are users are trying to access your application. It goes here, and there is ingress routing table. So now there is a feature in VPC which allows you to put specific routes in the VPC. So IGW, earlier you could not change the IGW routing, but now you can. So anything comes, you send it to gateway load balancer. How you send it? Via endpoint, as we saw. Send it to gateway load balancer. Gateway load balancer will encapsulate it via Geneve protocol. Send it to the actual gateway load balancer. It will send it to whatever security appliance you have. The request will come back, and here it says this whole VPC CIDR is local. It will be forwarded to here. The response will go back, and wherever it came from, it will go to the appliance it will check, because it has to be symmetric, by the way, right? So whatever appliance is being used, the traffic needs to go to the same appliance. It will take care of it, and the request goes out. So this is I'll share all these blogs. These all are publicly available information. So don't worry too much about it, right? And this is the east west. So there are so many components actually. So don't worry in case you don't know transit gateway or something. But normally we use transit gateway. So it is to connect various all the infrastructure together. So it is kind of central connectivity point, you can say, right? So if you want to go from um, FVPC 1 to FVPC 2, right? So this is how you go. So from here, you go to transit gateway. Transit gateway will forward the traffic to the appliance VPC, like security VPC in this case. Security VPC will have the gateway load balancer endpoints. It will send to gateway load balancer. It will go to appliance. The traffic will come back to the transit gateway. Transit gateway will send it to the destination, and the return traffic will follow the same path. Right? Now, there is a caveat in here actually, right? And this is very important. I have seen multiple customers, their architects, just missing this point, and this is where it goes little sideways. So AWS has an inherent policy, like internal policy within the traffic flow, that AWS will try to keep the traffic in the same availability zone as much as possible. So because of that policy, what happens if you want to send traffic from, say, source is in availability zone 1, destination is in availability zone 2. So suppose this is F1 VPC, this is F2 VPC, you want to send traffic, right? So what it will do, the traffic will come from availability zone 1, it will go to availability zone 1 transit gateway ENI, it will send the traffic to transit gateway keeping the same principle, that same availability zone, it will send the traffic to availability zone 1 where your appliance is. So suppose this is gateway load balancer, right? So your appliance, it will return the traffic, not return. So it's the same packet. It will come. Transit gateway will say, okay, where it is attached to. Now here it will switch the availability zone from availability zone to availability zone 2, because destination is in availability zone 2, so it will send to availability zone 2 transit gateway ENI, and the request will come here. So far so good, it's all hunky dory, but the problem starts now. When the request goes, it will follow the same principle. So availability zone 2, transit gateway will follow the internal principle. It will keep the traffic in availability zone 2. It will send to the appliance of availability zone 2. And all these security appliance, they are symmetric. So if there is no open socket, they will not allow the traffic to go back, right? It will drop the packet in here, because it does not know about the incoming connection. So how it can allow the outgoing connection, right? So this is called asymmetric routing problem. So it used to happen, right? So now so AWS came with transit gateway appliance mode. So you have to enable that. And by the way, appliance mode you cannot enable using GUI. So there is a command, right? If you search like how to enable transit gateway appliance mode, you can enable using CLI only for now. I need to check if it is changed, but as far as I know, you can only do it with CLI. So what happens? It will keep the traffic symmetric. So if you enable the appliance mode, transit gateway will make sure that it sends the return traffic to the same appliance or same firewall where it is came from. So this way the packets are not dropped. And always remember that, because this is, I have seen this problem, I don't know, so same problem so many times, right? So just remember that. So let's okay, we already did that auto scaling group demo, right? So okay, so let's see what is the time we have. If everyone let's quickly do it. So let's go through some load balancer demo, and after that I will give you the direct connect demo. um Give a discard. Okay, so let's quickly go through this. Okay. um So this is our same old console, right? So I have, just to give you, I have some preparatory work done. So I have two servers already spun up, right? So I call it server 1, server 2, and they are internet facing servers. So this 34.
Ashutosh, can you please increase the font
Oh,
size?
sorry, yeah, let me do that. Oh, this is too big.
Yeah, looks good.
Okay, so I have two
A bit
servers.
more, a bit more, a little bit more, and let me also make it full screen.
Yeah.
Yeah, cool. It looks
Okay.
good.
So I have two servers, server 1, server 2, just for the for the testing purpose, and they are internet facing servers, so that I want to show you something. So this is the internet IP, and this is the server. So it is like HTTP request. So this is server 1, right? So when you access that, this is a website, and this is server 2, right? Sorry, I could not make it any fancier, but at least it's a different color, so you know which one is which. So these are two servers, right? Now this is one way of doing things, right? You can give this URL. Suppose this is a URL to your customer, right? Uh, uh, Actually, this is a URL in case you want to use that. But yeah, so you can give this to your customer and give this to your customer. But this is not a good customer experience, right? You want to make sure it takes care of the switchover from here to here, load balancing, right? So what you want to do, you want to create a load balancer to load balance this, right? So let's quickly create a load balancer. And yeah, actually I have already created them. So I don't know. Let's create a new one. So, oh, by the way, sorry, I went too fast. Um, Create. So, when you create a load balancer, it will give you option which load balancer you want to create. So, suppose you want to create the application load balancer. It doesn't matter actually. These two, the configuration is more or less same. So don't worry. It will follow the same principle, right? So, just create the load balancer. Uh, so it is internet facing load balancer because we want to front our web application with it, and we want customers to access which VPC. So this is the BeSA VPC we have, where we have these two instances. And I told you, right, it will ask for the subnets which you want to use. So the availability zones, you select all the availability zones available, right? So this is, by the way, this is the subnet where I have my instance in, right? So I know it, that's why I'm selecting it, right? So these are the two subnets. So public subnet 1, public subnet 2, where I have server 1 and server 2 in here, right? Security group, I already created a BeSA security group. So basically that security group has two ports allowed. One is SSH port TCP22, and one is HTTP, the TCP port 80. So HTTP request, right? I have only two ports allowed in here. And then I need to create a listener. So listener is this load balancer will listen on which port, right? If the customer is requesting. So if it is HTTP, it will be TCP port 80. And when it listens, where it will forward to, right? So what you have to do, you need to create a target group, right? So I have already created a target group actually, wherein I have included all these instances. But for the completeness sake, let's create a target, right? So target group is basically where you will forward that request to. So in the target group, either you can have IP addresses, lambda functions, or you can have application load balancer also a target for the network load balancer. And this is a very peculiar use case wherein suppose you have an organization compliance and security requirement that you need to have a fixed IP, right? Whenever you create anything in AWS, you don't have too much control on the on the IP which AWS is assigning, right? You can have elastic IP address, but that is it, right? But if you want to have a fixed IP address, ALB does not support it. So you assign a fixed IP to NLB and front your ALB with NLB. And this is a very specific use case. And there is a lot of documentation available. That's why it is there. In case you are wondering how can a load balancer front another load balancer, this is what it is. right? So in our case, we have instances, right? Target group name, BeSA new target group, right? Port 80, yes, we are listening on port 80. This is HTTP version, so HTTP one is common. This is the VPC you need to select. So we have a BeSA VPC where we have two servers. Health protocol is HTTP. So we are checking health, that HTTP daemon is running, because server might be, a daemon might fail, right? And this is where my website is hosted. So this is at the slash one. You can change it if you want, right? And this is the health check. So you are performing your health check on which port? I'm performing check on the port where the traffic is coming from. You can change it. So the traffic may be coming on port 80. You can perform health check on port whatever 1000, doesn't really matter, right? Depending upon your need, but we are checking on the same port, right? So if port 80 is up, it means the daemon is running, right? Now health is threshold, as the name says, the health check should pass 5 times to make that instance healthy. Health check, if it fails 2 times, instance will be marked unhealthy. With every try, it will wait for 5 seconds. An interval, let's change the interval to 10 seconds. So between health checks, it will wait for 10 seconds, right? And this is the success score. So this is the HTTP success score. Nothing fancy in here, right? Next. Now you need to register targets, right? So you created a target group, but you need to register. So I have two servers in here. So I will register these two, include as pending group, right? And create target group. So this is the target group we have, and these are the two instances we have, right? And they are unused because we created the target group, but we do not have any load balancer fronting that, right? So we need to do this. So go back here, refresh it. We have a new target group, and rest all is, this is the basic configuration which we already use. Like these are the two subnets into availability zones. We are listening on port 80 and create load balancer, view load balancer. So now our load balancer is created. So let's go a little bit up. Sorry, it is actually too big, so scrolling is becoming a little problematic. Doesn't matter. Right. So it says if requests come on port 80, forward it to BeSA target group. BeSA target group has two two instances in it, right? So let's copy the DNS name. This is the public facing DNS name, and come here and paste it. It takes a little bit of time, so just don't worry. It will come. So let's just give it some time for that target group to have the instances healthy. So target registration is in progress. So it will take for 5 consecutive health checks, right? So it's on 10-second each. So it's around close to 1 minute, like 50 seconds. So just wait for that much time. When the targets are healthy, it will start serving the traffic. Okay, so targets are healthy now, right? So both targets are healthy. So if we go here, it should technically work. Okay, I don't know why it's not working. Oh, it is still. So it is still provisioning in AWS. Everything is little slow, but let's okay, it's active. Okay, so see, so this is server 2, right? Now if I refresh this, so another customer is coming, and it should switch, right? So the requests are cycling between these, right? So I have two servers. and all the requests are cycling between server 1 server 2. So it is load balancing the traffic, right? So this is a simple example of how the load balancing is working, right? This is maybe too simple, but I hope you got the idea, right? So we have two servers, it is equally balancing the load. So normally it is round robin, right? So it just selects, or secondly is the least connection, right? Least connection to the servers. So this is how it works. Now there is another uh, actually what you can do. So this supports load balancer, application load balancer supports based on the target as well, right? So what you can do, let me quickly show you. I'm sorry, we are running out of time, but I hope you can stick around for some more time. I wanted to show you something. Okay, so I created separate target groups, right? So these two target groups, so what I did, so you may have a case wherein you have, say, two servers. One server is serving a type of application, one server is serving photos, one server is serving videos, support, right? Or maybe invoicing application and billing application, two separate applications, right? You want, based on the http header or based on the query string in http, because remember, application load balancer works at layer 7, so it reads the http header, right? So based on the query string or the path, you can change which server it will hit. It will not load balance in there, right? It will see which server is registered for that target where that application resides. And so what we can do, we can just check that, right? So let's create. Actually, I think I already created one. Just a second. No, it's the old one. Okay, let's create one. Doesn't matter. So what we can do, we can create a load balancer, and this time we are balancing the load based on the query string, right? BeSA internet facing IPv4, BeSA VPC, both subnets, and this is security group. It's a good idea to always remove default security group, right? You don't want anything default, right? And then, oh, actually, this is in use. We need to remove that. Yes, so okay, doesn't matter. Let's see this. So I already actually used it. So in the interest of time. So this is BeSA ALB. So I already what I come on, how to scroll it. Okay, so when you create, so in here, what I was doing, since I already created, I'm not going to create it again, but I'll show you, right? So here I have created two target groups. One target group is I named it server 1, and wherein I registered server 1 as a target, and second is service 2 and server 2 as a target, right? So what I'm doing here, I have created a rule which says, if the query string is environment service variable 1, right, then the send traffic to target group service 1. If environment service 2 service and variable 2, send it to service 2, right? And if the query string has neither of these, then just the return a simple message that query string not matched, right? So, just to, for the completeness sake, so this is how you do it, right? So here you go. So you click on add rules, it will come. So add rules, right? It will, you need to insert rule, add an action. You can have based on the host header, based on the path, like slash photos, whatever, slash videos, http header. I use query string, and I said service equal to whatever, 1. Then send the traffic to target group 1. Service 2, send the traffic to target group 2, right? So this is what I did, just in case you are wondering how I did it, right? um, and that's it. So what will happen now, when, let's take the DNS name of this. What will happen if I do query string service, uh, so it is service equal to 1. See, so service, if query string says service 1, it will serve the server 1. No matter how many times I cycle it, it will not load balance across different servers, because it, this is a rule which says, because this is the application, right? We don't want it to send to the other application, right? Now, if I do server service equal to 2, yes, it's still doing its thing. So it should go to server 2 actually. Yes. Okay. Okay, maybe something messed up. Load balancer here. This HTTP. Let's quickly just see if maybe this root server time. Maybe while saving, I made some mistake somewhere. We can figure it out. If it takes too long, then probably we'll just leave it. But just wanted to show you the idea. So the rule says service 1. Okay, so service 1, service 2, query string 2, service 2, return fixed response. So yes, this is correct actually. It
Can
should
you
that.
check the URL correctly? I think the URL might be having a typo.
Okay, okay. Let's copy again. So this DNS name. Yeah, because there is not much which can go wrong actually. Sorry. Question service equal to 1. Yeah, this is working. Service equal to 2. No, there's some. I don't. Oh, it's just slow. Okay. So yeah. So now it is serving. If my query string is service equal to 2, so it is serving the another application, right? So you can have it like, you can have a path also, like suppose you have path like cat pictures, then it will show you the servers which are serving cat pictures and dog pictures, whatever, right? So this is what I wanted to show you. So service 1 will always serve the server 1, service 2 will serve the server 2. Now we have one more, right? If it does not match, so what, service 30, right? What it will do, it will just give a string like query string not match. This is just a text we have put in there, right? So this was a simple example of ALB. In NLB, you cannot do any of this, right? Because this is HTTP header. HTTP is an application which is layer 7. You can only do in ALB. You cannot do in NLB. In NLB, it just works here, right? So that is it from demo point of view. And if you are interested and people are available, we can go through the direct connect. Let me know. So this is actually NLB also. I just created one, right? So NLB, and we have uh, a target group for NLB created, and in that target group, I have two instances, same server and one server two. I told you it's just same, right? So if we come here, just paste that. So this is the uh, NLB URL. If I paste that, it will do the same, right? So it is server two, and it will cycle. And sometimes it becomes little cheeky. So what we need to do is just because of the cookies. So I have to just do this. Sorry, here. Right, it is the cookie, so don't worry, it's working fine. It just somehow sticks. So so this is the same URL, but it is cycling between these two servers. So this is the NLB demo. It's more or less the same, right? Okay, so let's uh, what mm, okay, direct connect. We I don't know. Prasad, shall we? Can we go a little bit over if not too long, and we can go through direct connect. What do you say?
Yes, I think it should be fine. Like I know we are over time. How much time is going to take?
Maybe 20-ish minute. I just want to show because this is something or maybe make we can have a next session and we can go through in detail.
So I'll ask the folks, like, should we have it, because the 20 minutes would be a long time, like, and I think, instead of rushing it, we can have a half an hour session in one of the upcoming session, or do you want to folks to see now? We can provide another 30-minute slot for the next session. Okay, few people are saying next session, please. Obviously, Saturday people will be having, like
Yeah, actually,
time,
and
and they,
yeah, this is important
obviously
concept,
there
and I
is.
don't want to rush it because see, for me, I do it day in day out, right? So I may go a little bit with the speed, right, and which I don't want to do, right? So let's do it next time, and yes,
Sure.
and
From the next session, folks, as you know, that we are finishing the technical track, 8 weeks, and for the next session, it is like 4 weeks now. Our uh, behavioral track starting. But what we will do is that we will reserve 30 minutes for Ashutosh in the next session, and yeah, Ashutosh will show the demo of Direct Connect. And in case if there is any other request, feel free to let us know either here or on the LinkedIn group if there's any specific technical topic that you would like us to dive deep into, or any behavioral topic that you would like us to dive deep into. Please let us know, and we will accordingly get the guest speakers, or we'll accordingly try and cover. There's a request for ECS. Okay. Good enough. ECS is a separate topic altogether. It'll take probably a full one session. Next session is Easter holidays. Yes, it is actually for us. Uh, but
mm,
Ashutosh, will you be available next weekend?
oh no, actually, I'm going out.
Then
So
probably next weekend then.
yeah, yeah, yeah,
So
yeah.
it's
Most of the time I'm available, but my kids' holiday started, right? So we have to go somewhere.
yeah.
But yeah, then I will see. And we have the setup available, right? It is our setup. So let's do it properly because I really don't want to rush. And I have all sorts of resources, workshops available, like hundreds of workshops, and we can have a networking whatever you want to do, right? So don't worry about it, and feel free to share your queries in the I oh, by the way, Prasad, do we have any interaction mechanism, like if anybody wants to ask any question offline, how does it work?
We do have a LinkedIn group, Ashutosh. Let me add you to the LinkedIn BeSA group. So we have
Yeah.
around, like, I think 3,000 plus people now, like, and we like keep interacting there. So let me add you there so that you can create a post about all the resources there also. And anyways, we'll be posting it on our, like, GitHub page resources section. But we can start a thread specifically on this on our LinkedIn BeSA
Uh,
group.
that is great. That's great. Okay, I'm sorry. Somebody asked this. What is the priority value? Sorry, I did not see it. So, see, the priority value is the rule priority. Like how, what is the evaluation order of the rules, right? Priority value, one rule will be evaluated first, then the second rule. It is just that. It's just a rule numbering, right? Um, and I'm sorry. Apologies in case I went too fast because I wanted to give you, idea about a few things, and I appreciate. See, in case you did not get something, just don't worry. See, I did it for 20 years, right? So for me, it is like you know, everything is kind of in my brain. But if you don't get anything, just don't worry. We can, I'll just guide you through the process, and I'll share some nice workshops from basic to advanced, and you can go through it. And any networking queries, feel free to ask. We already have so much public resources, but just in case you want, please feel free to reach out. And I hope it was good use of your time. And sorry to bother you on the weekend. And enjoy the rest of the day.
No, it was for me. It was a good learning. There are a few basic things that I know, but there are a few deep dive things that like I was not aware of, frankly. And even for the basic things, it's always good to get a good refresher. So yeah, I think it was, for me at least, it was really useful, and I'm sure it was same for everyone. So, anyways. Uh, Yeah, okay. There is a request on CPU hogging script share. We will do that. Anyways, I'll add Ashutosh to the LinkedIn BeSA group, and then you folks can like directly reach out to him, or anyways he'll be available on LinkedIn. Anyways, you feel free to message him directly, add him to your network. And as I said, like one of the best networking SA I've worked with. So he's
Oh,
great, technical guru. So thank you everyone for your time today, and see you next week for the session of behavioral. And we will book a slot with Ashutosh for most probably 15th, the week after Saturday, for the Direct Connect demo.
okay, then. Thank you, everyone.
Okay,
Have a
thank
good
you
rest.
everyone.
Take care.
Take care. Cheers, guys. Bye bye.
Bye.